here's a tool that you can use. I'll state it as a theorem. Let an be a sequence that's defined by a function, say f of x, which we'll say goes from R to R. It's not, so what does that mean? That means that an is literally f of n. Then the limit as n goes to, say, infinity of an is the same thing as the limit as n goes to infinity of the function. No, sorry, limit as x goes to infinity of the function f of x. So we can use this to calculate limits of sequences. And so what is a limit of a sequence? So we use this to calculate limits of sequences, because in practice most of our sequences come from explicit formulas. So we can use this to compute what's called the limit of a sequence. And of course, we all know what a limit of a sequence is. A limit of a sequence, well, there's a precise definition, which you know from Calc 1. So remember that the limit of the sequence is just saying what number. So the limit of the sequence an tells you what number, if any, the terms of the sequence approach as you go further along. In the sequence. Okay, so sorry for this bad handwriting. So for example, if your sequence is 1, 2, 3, 4, etc., then there is no limit. There is no limit. Because the further out you go, the numbers aren't getting closer to anything. They keep getting bigger and bigger and bigger and bigger and bigger. On the other hand, if you consider this here, sequence 1, 1/2, 1/3, 1/4, 1/5, etc., on forever, ever, then the limit is actually 0. Remember, there's a distinction. The sequence is getting closer and closer and closer and closer and closer and closer to 0, and so we say it's the limit is 0. But notice that 0 is not actually in the sequence. Note that that 0 is not actually in the sequence. This is an important. That's the whole point of limits. Note that 0 is not in the sequence itself, because terms in the sequence are, of the form 1 over n. And so if n is really, really big, then this is really, really small. So if you take a really, really, really big number, it's really, really small, but it's still positive. So it's impossible to construct 0. You're still doing 1 divided by something. 1 divided by something can never be 0. So that's the subtlety between limits and not limits. So let's just do a couple of actual calculations here. So say we have this sequence here, 3n squared minus 2n plus 1 all over n squared plus 3,000. So this is a formula that's going to define some sequence. So the first number is 3 minus 2 plus 1 divided by 301. The second term is 3 times 4 minus 8 plus 1 divided by 304, so on and so forth. And so how do we do it? Well, since the way so let's calculate the limit. What's the limit of the sequence? So as n goes to infinity, what's the limit of the sequence here? Well, by the theorem over here, it says that to calculate the limit of a sequence, if it's expressible in terms of a function, then we're just taking the limit of the function. And here it is implicitly defined by this function. So this is the same thing as just calculating the limit. In fact, I'm going to write it x right now just for consistency purposes, but you don't even need to use an x. You could just keep the n. So now you remember from calculus 1 how to take limits of things like this. And limits are super well behaved. So if you calculate the limit, which I trust you can do, you'll see that this thing is actually equal to 3. So this thing is actually equal to 3. So that's an example of how we calculate limits of sequences. So here's another example. Let the sequence, say, Bn is given by, say, cosine of n. So I'm going to use that to define a sequence. So for example, B1 is cosine of 1, B2 is cosine blah, 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 blah. And it turns out that in this case, so the limit as n goes to infinity of this sequence does not exist. And that's just because the cosine function, doesn't have a limit. If you consider the graph of cosine, the graph of cosine goes like this. So it doesn't approach, the further out you go, it's not like the outputs aren't getting closer and closer to anything. The values continue to oscillate, no matter how far out you go. So there is no limit. So this is the picture for why there's no limit. Anyway, so that's just a brief reminder of what a sequence is. So a sequence is an ordered list of objects, and it's really just a reminder on the notation, and then a reminder on calculating limits.